Yeah, welcome to our webinar with the topic how to build your own GenAI-based knowledge management system. I'm really happy to share our experience that we had by building up our own GenAI-based knowledge management system last year. Small disclaimer, we are not yet an AI specialists, but data specialists. But if you aren't either, you will get the perfect intro to build up your own LLM-based system using open source technology. And you will see how we did and what our experience is, and you can do it yourself as well. So you will learn how to add your own knowledge to an LLM-based knowledge management system, how to use a robust data integration layer to seamlessly ingest new information into your LLM-based system, how to build a reliable and truthworthy solution by providing the sources and validating your answers, and how to meet strict data privacy and security requirements with a full containerized solution. My name is Carsten Schweiger, and I was part of the project team last year as we implemented our knowledge management system AI-based last year. And yeah, if you have any question during the webinar, please use the Q&A feature to add your question, and I will answer the question after the presentation at the end of the webinar. And if you have after this webinar still questions, please don't hesitate to contact us. Here's also my email address on this screen, and at the end we also will give you the contacts for Data Vault Builder, possibility to contact us. So let's start. So what was our challenge? Why did we start this project? The key challenge is getting the right information. Yeah. So our information data is in different sources. The knowledge is spread over a lot of places, tools, documents, applications. So we have different wikis, Confluence, for example. We have Jira support tickets. We have Office documents. We have a lot of videos about Data Vault Builder, about the product. So also the transcriptions of these videos. We have manuals and we have websites, our website, our blog. We also have our product documentation on the website. So, and we have different roles, of course, in the company. For example, here, sales, development, and support. And yeah, how to get the desired information. So at the moment, without an integrated knowledge management system, or before the project, let's say like that, not at the moment anymore, we need to know where to look exactly. And we need to know what is the right keyword to search it, the search term. And then if you know the place and the keyword, you get the desired information quite fast. But if not, you ask somebody who knows. Yeah? That is inefficient because it pulls colleagues away from their work. Yeah? Don't get me wrong, it's nice to talk with the teammates and collaborate, but it shouldn't be needed for basic information lookup. Yeah? There should be an easier way to get the common knowledge out of your knowledge base. So can this be done more efficiently was our question, and how? So the goal was easy, simple goal. We want to ask a question to our knowledge management system and get the desired information. And of course, it would be nice to use a natural language if the knowledge management system understands the natural language and can give a human-like response. So you have an idea what we did, yeah? That's why you are here. Nowadays, we call it the large language model in between that understands this language and can also respond in a human-like way. So we took a large language model. We took ChatGPT and tested it. we asked ChatGPT how much cream should you put onto a hub in Data Vault Builder. So if you don't know what data modeling means, in this data vault modeling, there are hubs, and these hubs are core business concepts. You can call them also business objects or business entities. It's not important to understand the punchline from the slide. But the answer of ChatGPT was, in Data Vault Builder, cream typically refers to the business views or the presentation layer that sits on top of the raw vault and business vault layers. It allows users to create meaningful, aggregated, or transformed data views for reporting and analytics. Sounds nice from the words here, or from the words, but it is, of course, completely nonsense. There's no cream in the presentation layer. So what is one big challenge with a large language model? They can hallucinate. They produce inaccurate and entirely wrong or fictional information. So the LLMs generate a text based on patterns and probabilities from their training data, but they lack true understanding. They don't have the true understanding of that. They just combine it in patterns and probabilities. So hallucination occurs when the training data is inaccurate or conflicting. And if the model then tries to fill gaps by inventing plausible but false information, and if there's no built-in fact-checking mechanism. Yeah? So we thought, okay, we need the correct and accurate answer. And how can we implement our knowledge from all these sources that we've seen into the LLM that we get from a generic large language model to a domain-specific large language model so add our product knowledge, our technology knowledge, our industry knowledge. So the question is how to get from the generic to the specific one. Let's see, next slides, how we did that. So first, you start and think about what is the best solution. And of course, you start with a market research. So, but this is not so easy actually, because the market is evolving very fast, and it's almost impossible to get a whole overview. So we had some tools that we tried and looked for them and had our requirements written down, compared it to the market. And here you can see some examples that doesn't have any claim to completeness, is just examples, and it's also half a year old. So that were tools that we looked at, and we tried to categorize them. And during our research, we found out that we are able to create our own open source based system. And that was then the thing we wanted to try. So from the overview, how it should work, yeah, we have a user. The user interacts with a generic LLM. This generic LLM should somehow get our specific data. And also we didn't know what framework we're using now and how we do it. But we found out that if you want to implement your specific data actually in an GenAI application, you have two options: the fine-tuning and the RAG, the Retrieval Augmented Generation. The fine-tuning is just adjusting the model while further training. So you train, you take the model and you train it further. And you need to do that for updates, but this is expensive and time consuming. And the advantage is it's working offline without any external database, data source. So the LLM can be capsuled. You can ask it and it gives you the information back. It's very easy from the infrastructure, from the whole setup, from the solution. But it's more prone to overfitting and hallucination than the RAG. Overfitting means that the model memorizes the training data too precisely and loses the ability to give a generalized answer. So in my opinion, I think it's a completely different opposite of the opposite effect of the hallucination. The hallucination, the large language model just makes something up to fill gaps, and in the overfitting, it keeps too precise at the new learned topics and doesn't have the possibility to generalize, to abstract anymore. The RAG is another possibility. You can use an external database to retrieve your information dynamically. It requires this external database, knowledge base, of course, and a retrieval process, retrieval infrastructure. But you have no need to retrain your model. And so it's much more easy to update your data if your information changes. And this was a very important point for us, because Data Vault Builder always have new features, and we need to update our product information. Otherwise, it's getting outdated very early. So this is very important for us. And yeah, but the disadvantage is you're heavily dependent on the quality and relevance of the retrieved informations from your knowledge-based system. It's also possible to combine both things in a solution, but we choose RAG because of our goal was to minimize the hallucination. We want to get the most accurate data out of it, and as I said, want to update the information very often. So how does RAG work in detail? So to keep it simple, first we have two processes, and out of these two processes also two components. So we have the Retrieval Augmented Generation process on top, where the user interacts with the LLM. The LLM somehow gets specified data and sends it back, and this specified data needs to be prepared. Yeah. So these are the two processes. First process, data preparation. That's what we are used to do with Data Vault Builder. So that was for us quite easy. We took data sources from all the different documents, applications, and we integrated it to one database. We cleaned it and we chunked it in smaller pieces. The smaller parts can be processed optimized by the LLM, and we need to embed the information to a vector database. So here, the embedding to the vector database, we will have a slide soon to explain that more in detail. Also the chunking. To have these, let's say, interface between these both worlds, the data preparation and the retrieval augmented generation. The second process then is the communication from the user to the large language model with a question. At the same time, the question gets embedded into to search in your vector database for the same embeddings, with the same meaning, not for the same text, but for the same meaning. We will see that soon, and give the result back to the the generic large language model. And with this result, with your knowledge chunk, that is the result of the search, and the question, the generic LLM generates the answer and response to the user. So this is how the process works, and we will go there more in detail. You also see, okay, the large language model is can download it. It's open source. You can get a large training data from a large training data set, and then you can use it for the communication. The embedding itself on both sides, first embedding your information to this knowledge database, let's call it, and also the searching is done with another LLM. So you have you need another one because you need an optimized one to do this task. Probably that the search works nice. Yeah, let's go to the chunking. What is the chunking? The chunking limits the context size. That means the LLM gets the right context to answer more accurate. So the embedding is more accurate if the text is structured in smaller chunks. So if the chunks have the right size, the chunk includes the relevant data for the right answer. And also smaller chunks are more efficient to process. And from our experience, the best format is also like to have a question and an answer in your knowledge chunks, or have a speaking header and tags and then the context for it. For example, here, you cannot read that, but I can explain. This is a article of our knowledge base. It's about integrating and unifying data. And there are different ways to look at it. There's the integration part and the unification part, for example. And having this big document into smaller chunks helps to retrieve the right information and to give more accurate answers. So this is a really important part. And the second thing we want to see more in detail is the LLM embedding. What does it mean? I already said it. You capture with embedding the semantic meaning of the text, and you save it to your vector database, and you search with the semantic meaning the corresponding correlating text out of it. And the thing is, you compare according to the meaning and not according to the text. So it's not a text comparison, it's not a string comparison, but a comparison of the meaning. Let's have a look at this example. Yeah, there are different embedding models. You have to find out which one is the most accurate for your use case. There are with hundreds and thousands of dimensions. And if words or text are embedded to these with these LLMs, the text is weighted according to the dimensions. So we see here, for example, man and woman, both is human, so the value here is quite high. Yeah. Or if you look at the dimension gender, you see it's more like the opposite, man and woman here. Yeah. King and queen also here have a high value and human, and a high value and royalty, but the man and woman doesn't have a high value at reality. Yeah. So this is just to get an idea how this works with embedding. So you bring your knowledge chunks to the database, you embed it with these, I think our model had like 1,024 dimensions, and it gets sorted in to find similar texts for your question. Similar in the meaning and not only in the text. So this is a difference, a part of a normal string compare. So how does this work in practice? Before we go to the solution architecture and the components that we used, I will show you that as well. We just have one example how the process works. So a user has a question, provide, let's call it a prompt, provide a summary describing what Data Vault Builder is for. This one is embedded to the vector database and the search is done. And the search finds this knowledge chunk with the context. Data Vault Builder is a business-driven data warehouse automation tool that reliably powers self-service business intelligence, data analytics, and AI applications. It streamlines decision-making process with robust governance and effortless auditability, supporting the full data warehouse lifecycle. It includes data modeling, code generation, integration, deployment, scheduling, and operations. And it also says here the source where it comes from our internal wiki. So this was the marketing part of this webinar. Remember, this box is very important. And you have another one, the system message. Yeah. The system message you can compare if you use ChatGPT or other LLMs. You can explain at the beginning, if you customize them, always how should they act, or how you want them to react on your response. And here, for example, we have a prompt like, you are an assistant for question answering tasks. If you don't know the answer, say that you don't know. Use 3 sentences maximum and keep the answer concise, and add relevant sources. So here you have the important thing. If it doesn't find anything in the vector database, it should say, I don't know, instead of making things up. And it also should give you the sources that you can check the sources to validate the answer. So to generate the answer, the generic LLM takes the system message, the human question, and the context, and formulates the response and delivers the response to the user. So this is how it practically works. So we have these 2 processes, but what is the technical architecture behind that? So for us, it was important to have a Docker-based solution, actually, because Data Vault Builder itself is Docker-based. The advantage is you can deploy it on any Docker host. It could be on-premise, on your own Linux server. It could be in any cloud. You can easily change the cloud provider and move it from one place to another. You can easily scale up your solution while deploying more Docker containers. And if you host it then in your own data center, you have an isolated version. So you have high data privacy and security requirements that you can meet with that solution. So we have here again our 2 processes, and let's start to look in the middle at the core of the solution, what we used. So for running the LLMs, we used Ollama. It's a platform to run LLMs. It's open source. And we had 2 different LLMs. We tested several ones, and we then found out, especially at the embedding side, you have to test difference, because depending on your context, depending what you're doing, you need, for example, you need one that works also good for technical texts, technical context. And we took from MixBread AI this embed large model. There are several versions now out of this as well. And for the generic response, we took Llama 3.1 8B from Meta. This is also open source, a very big model, and they are running on the Llama platform. And for the communication with the Llama platform, we use LangChain. That's a framework, a Python library actually, and we use it for the preparation process to create the embeddings to the knowledge database, and we use it for the retrieval also to create the embeddings, both with the MixBread AI model to generate the response. Actually, the response uses both, of course, LLMs. Yeah, and as a knowledge database, we took a Postgres, also open source, but with the PG vector extension. So with this extension, you can use it as a vector database, and you can hold the prepared information chunks and the embeddings in this database. So that was here in the middle. For the user communication, we use Streamlit. It's an open source framework to rapidly build and share beautiful data science and AI web apps. It's easy to create a chatbot. Our goal was to have a chatbot where you can communicate in a natural language. So this was easy to create. And if we look at the screenshot, we can see what we did. We also had the possibility now here to specify the sources. So that makes sense if you know where it is, or if you want to have it from the official documentation, not from another wiki or something. You can here say what should be included in the search. We also have a fast checkbox for including or excluding support tickets. We also have the possibility here to change the system message. Yeah. And also very important to improve your knowledge management system is this feedback. We implemented a small feedback section where you can rate the answer. You can give your name for further questions, and also tell what you expected if you didn't get the right answer yet. And you can see you can have a chat like you used to from other chat box. How can I combine multiple CSV files to be loaded as one source? And it explains how you can configure these files are indexes, and you can specify a regex pattern to load that. And we get the sources also. So here, in this example, it's a very good example because there were several search algorithms, and there's a prioritization, which are what is the right most accurate information. And here in this case, we have 3 times the same source, the same page in our knowledge base. Actually, here it's Confluence knowledge base page, and it found the same information of 3 different texts, and so it's quite accurate, and also the text here is correct, so that worked well. Yeah. So the last part we want to look at the solution is the data preparation part with Data Vault Builder. So we use Data Vault Builder to get all the data in from different sources, from Excel, from Jira, Confluence tickets. We wrote our own Jira and Confluence connectors for this API, YouTube videos, so the transcriptions, web pages. At the end, we connected to 10 different sources. In Data Vault Builder, we managed the data model and the orchestration of the loads. And we prepared the data to generate also different versions. So we had different versions to find out what works better. So which different sizes of chunks. Also we'll see that later with different embedding models. That makes sense to have a flexibility here to try out what best works. And with Data Vault Builder, we of course can incrementally update our data. At the moment, we have a schedule here for every night. So every night we get our knowledge base up to date. So now the question, did this work? Does it work? Yeah. What is the result, and what are our learnings of the project? So we tried it out with the same question again. How much cream should you put onto a hub in Data Vault Builder, and our own Volty, he'd be calling the robot Volty. Yeah, Volty was answering, I don't know. The provided documentation and videos about that will do not mention adding or using cream on a hub. Yeah, because it's nonsense. So the question was already tricky. And it gave us the sources as well. So that is now the important thing. Instead of hallucinating, we have a solution that tells us that it doesn't know what is the most value out of it. We also tried here with different other questions. How can I influence the load prioritization decree in Data Builder? We tried with ChatGPT, and if you read that, that sounds at least realistic. Yeah, if you know more about Data Builder, you see, okay, that's wrong, but it's not so that the information is, there are parameters, it's an XML file that it's all possible to configure data like this, but actually it's also nonsense. On the right side, we have now the right answer and we get the right configuration values and how you do it, also with the sources for the detailed documentation about it. So an example of a good quality result, but of course you can also have the generic part can also hallucinate still. So very important to check the responses. Here in this example, we asked, please generate a Docker Compose to run a Snowflake database. So this was also a tricky question. The question already is nonsense because if you know Snowflake is a cloud database and we don't have any information how they deploy it and configure it, and you cannot deploy it as a Docker container as well. And now our LLM also makes something up. It takes the Docker Compose file from our configuration from Data Builder and mix it up with some Snowflake parameters. So this is wrong information. At least if you click on the source here, you will find the right configuration, how it works, and you will see that this is hallucination. So what did we learn out of this project? Overall, we were really happy. So we have good results. We learned that you have to try different LLMs for the embedding, especially. Different approaches for chunking. We also need to restructure our documentation to be able to split it into smaller parts automatically. So there's some manual effort to do as well to get good data quality, like always. The size of this fetching chunks is very important for the best results. Also, this algorithm, how to prioritize them, the research results, helped us a lot. We tried different versions with the searching for the question and the answers, or only for the question and getting out the answers. So and prioritizing these results, to get the best results. And this is you have to you should have a solution where you can change these algorithm quite easy to have different versions to compare them. And for us, it was also very good to filter the sources. So if, for example, you have a fine-tuning version, so you train your model, you cannot filter anymore. The data is in, and you cannot say, I don't want to have it from this source, so I need it from another. So this is also the big advantage of the RAG implementation, that you can choose which parts should be searched and which not. For a fast response, we also learned you need a GPU, so you need the graphic card and not only the CPU. The large language models in theory runs on your laptop as well. So this is working, but you wait 10, 20, 30 minutes for the response. So, but the GPU makes a big difference. So we had a GPU with from GeForce with 24 GB of RAMs, and this works smoothly now. And of course, the language matters also in our solution, of course, and not right, because in ChatGPT, then I think the language doesn't matter at all, and the translation is really good. But we didn't implement any translation engine so far. So for us, we found out if you ask in German and add all the documentation in English, you get not the good results. Then you get it if you ask in English. So the language matters a lot at our implementation, but there are ways how to implement a translation engine as well. Yeah. Now the bad news, or let's call it the truth. Yeah. If you have bad data quality in, you get bad quality out. So the wisdom shit in, shit out still is true. Also with LLMs, that's our experience. So the data need to be collected, transformed, and yeah, sorted and having good quality and good right chunk sizes. And yeah, you also you need a stable data preparation layer to test different embedding LLMs. So the separation of the data preparation and the retrieval like we saw in the solution and also here on the right side. Yeah, this separation makes a lot of sense because then you can independently update and test different versions on the rec side, and you can test different data preparation and chunkings on the data preparation side. And of course, the LLM part is evolving very fast. So it's good to have a knowledge base independent of that you can use it also for other newer models in the future, or also to take the same same prepared database for different application, different chatbots, perhaps one for customers, perhaps with a limited data set, and another perhaps for internal users with the whole data set, or even limited depending on in which department you're working. So this persistent layer helped us while developing very much. The question is, did we achieve our goals? Actually, yes. We have our own AI that uses our own data sources and our own knowledge. With each answer, we get the sources and can quickly validate the answer if it's right or getting further information. The solution runs fully containerized and isolated from any third-party application, hosted at our place. We could easily move the hosting to the cloud if needed. And we could, because containerized, you could also, with almost no effort, easily deploy another test system. Now we have the production live, and we want to have a separate system to test to development changes, improvements. And of course, the containerization allows us to scale, and we don't need a lot of maintenance. And yeah, we can update it stable every night. If you have any question about the tool, you can book here with this QR code your own individual demo, or you can contact us at contact@datavoltbuilder.com, or directly if you want to ask questions to me, please use my email address as well. Also here, our Volti could answer how to address us. That is very easy and good. So now we are at the end of the presentation. Thanks a lot for your attendance, and I check now the questions.